Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 1, Section 4, titled Adding Real Numbers. By the end of this video, you will have reviewed methods for adding real numbers and applying addition. This includes reviewing using a number line model, adding numbers, evaluating expressions, and adding matrices. Additionally, you will review a couple real-world problems using real number addition and subtraction. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to my channel if you find this video to be helpful and give a thumbs up. That'd be very nice. Thank you. Okay, so before we get started, I'd like to look at a couple definitions. An additive inverse. The opposite of a number is its additive inverse. Therefore, a number added to its additive inverse would equal 0. Look at the example, 3 plus a negative 3 equals 0. The negative 3 is the additive inverse of 3. An element. You identify the size of a matrix by the number of rows and columns. Each item in the matrix is an element. Therefore, a 2 by 2 matrix would have 4 elements, and a 3 by 3 would have 9, and so on. Okay? Okay, objective 1, adding real numbers. In a previous math course or courses, you've learned that the sum of a number and 0 is the original number. This is true for any number, whether it's positive or negative. So here's a property. The identity property of addition. For every real number n plus 0 is equal to n. And some examples of that. 0 plus 5 is equal to 5. Negative 5 plus 0 is negative 5. The opposite of a number is its additive inverse. We just talked about that. The number line shows the sum of 4 plus a negative 4, right below. So let's look at that. So we see on the number line, here's 0 right here. And it says 4. So at the end we got 0. It says 4 plus negative 4, right? So start at 4 and move to the left 4 units. So we started here and we move 1, 2, 3, 4. So end at 0. So 4 plus negative 4. You start at 4 and we subtract 4. 1, 2, 3, 4 from it. And what do we get? We get 0. Continuing with objective 1, the additive inverse of a negative number is a positive number. The number line below shows the sum of negative 5 plus 5. So like we did in the previous slide, here on the number line, we're starting at negative 5, right here. And we're going this, so negative 5 plus 5. So we move to the right. Plus is moving to the right. 1, 2, 3, 4, 5. And where did we end up? We ended up at 0. How about another property here? The inverse property of addition. For every real number n, there is an additive inverse. So negative n such that n plus negative n is equal to 0. Example, 17 plus negative 17 is equal to 0 right here. 17 plus negative 17 is 0. How about negative 17 plus 17 is 0? Okay, good deal. So example 1, using a number line model. So we're going to look at these additive inverses and such using a number line. So simplify each expression, okay? You can use the number line as a model for to add real numbers, it says. So in A, 2 plus 6. So what are we going to do? We're going to start here at 2, starting at 2, and we're going to add 6. And we do 1, 2, 3, 4, 5, 6. We end up at 8. So 2 plus 6 is equal to 8. Here it is right here. 2 plus 6 is 8. How about B? 2 plus negative 6. So we're going to start at 2 right here, and we're going to add negative 6. So adding negative 6 means moving to the left 6. 1, 2, 3, 4, 5, 6. We're at negative 4. And 2 plus negative 6 is equal to 4. Excuse me, negative 4. How about C? Negative 2 plus 6. So we're going to start at negative 2 right here. We're going to add 6. 1, 2, 3, 4, 5, 6. We end up at plus 4. Negative 2 plus 6 is equal to 4. And finally here at D, negative 2 plus negative 6. We're going to start at negative 2 and we're going to subtract 6, which means go to the left. 1, 2, 3, 4, 5, 6. We ended up at negative 8. So negative 2 plus negative 6 equals negative 8. Okay, example 1, check your understanding. Directions, use a number line to find each sum. And if you've done these with me in the past, you know that I just ask you to stop the video, work them out, and come up with the answers, and then come back, start the video, and we'll go over them together. So I'll wait for you. Okay, I'm assuming and hoping that you stopped and tried them, and here we go. We're going to answer these together now. So problem A, what is negative 6 plus 4? Well, if we did the number line, we could do that. We can draw a line. Let's see if we can do that. Negative 6. We're going to call this negative 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. How's that? 5, 4, 3, 2, 1, 0. So here's 0 right here. So we're going to go negative 6 and we're going to add 4 plus 4. 1, 2, 3, 4. Where are we? Negative 6, negative 5, negative 4, negative 2, negative 1. Oh, I forgot 3. Excuse me. Sorry. Gotta learn to code better, huh? 5, 4, 3. Let's get 3 in here. Negative 3. And then finally negative 2 right there. So negative 6 plus 4 is equal to negative 2. Negative 2. How about 4 plus negative 6? If we draw that number line, 1, 2, 3, 4, 5, 6, 7, 8. We're going to start here at 4. We're going to call that 4. So this is 3, 2, 1, 0, negative 1, negative 2, negative 3. So 4, we start at 4 right here, and we add negative 6, which is move left 6. 1, 2, 3, 4, 5, 6. Right here. So if you take 4 and you add negative 6 to it, you're going to end up with negative 2. Right here is your slope. We start here and we move to negative 2. Negative 2 is our answer. How about negative 3 plus negative 8? Well, we're going to start here on the number line at negative 3 right here. And we're going to go 4, 5, 6, 7, 8, 9. And if we do that, we're going to come down to 9, 10, 11. Okay, we're going to subtract 8. So 1, 2, 3, 4, 5, 6, 7, 8 right here. So if we start at negative 3 and we travel negative 8, that's to the left 8, we end up at 4, 5, 6, 7, 8, 9, 10, 11. Negative 11. Negative 11 is the solution here. And now finally we have 9 plus a negative 3. So if I draw the line and I say we're here at 9, and we're going to add a negative 3. So 8, 7, 6, 5, 4. I think that's far enough. We started at 9, and we're going to subtract 3. 1, 2, 3. And this is 8, 7, 6. From here to here gives us 6. So 9 plus negative 3 is equal to 6. Okay, going back to our first objective, looking at another slide here, adding real numbers still. You could also find sums in example 1 using rules instead of the number line. Okay, recall that numbers being added are called addends. A-D-D-E-N-D-S, addends. Okay, so rule 1 here, the first rule. Adding numbers with the same sign. To add two numbers with the same sign, add their absolute values. The sum has the same sign as the add-ins. Well, it's two numbers, right, of the same sign, so it doesn't matter if they're negative or positive. If they're both negative and both positive, you add the absolute values, which is in this, the first one there is 6 and 2. You add them together and you get 8. But what is the sign? Is it negative or positive? Well, since both add-ins are positive, and this first rule is talking about or like sign, so it's going to be positive. If they were negative, looking at the next one here, we're going to have negative 2 plus negative 6. 2, absolute value of negative 2 is 2. Absolute value of negative 6 is 6. 2 plus 6 is 8. Here's our 8. But what's the sign? Well, it's negative because both signs are negative, so the solution is negative, negative 8. The next rule, adding numbers with different signs. It's basically the same, except there's a little bit of a hook here. To add two numbers with different signs, find the difference of the absolute values. So now instead of adding them, we're finding the difference, okay? And then the sum has the same sign as the add-in with the greater absolute value. So let's look at this. We have negative 2 plus 6, and we're saying it's 4. Why is it 4? Because you subtract these two. 6 minus 2 is 4, and you take the sign of the larger add-in. Well, the larger add-in here is 6. The sign for the 6 is positive. In this next one next to it here, 2 plus negative 6. Well, you subtract the absolute values, and you get 6 minus 2, and you're going to get 4. Well, is it negative or positive? It's negative because the add-end with the larger absolute value, which is 6 in this case, is negative. So the answer is negative. Example 2, adding numbers. Simplify each expression. Let's try a few of these. So problem A, negative 5 plus negative 6 is equal to negative 11. They're the same. They're both negative signs. You add the values and you get 11, and you take the sign of the largest, but or either of them. It doesn't matter. They're the same. So it's negative 11. Since both add-ins are negative, add the absolute values, and then the sum is negative. How about B? 13 plus negative 34 is equal to negative 21. What do? You take 34, they're opposite signs now, right? So we're going to subtract them. You take the larger add-end, 34, and subtract 13, you're going to get 21. Now, what's the sign? Negative or positive? Well, you look at the sign of the larger add-in, or the add-in with the greater absolute value. So the difference of the absolute values is 21. The negative add-in has the greater absolute value, so the sum is negative. How about this one? 3.4 plus 9.7. They're both positive, and that equals 13.1. Both add-ins are positive, and their absolute values add their absolute values. The sum is positive because they're both positive. And then D, negative 1.5 plus 3.4. So they're different signs. So we're going to subtract the absolute values. 3.4 minus 1.5 is 1.9. And is it positive or negative? It's positive because the add-end with the larger add-end has a positive sign. The difference of the absolute values is 1.9. The positive add-end has the greater absolute value, so the sum is positive. Okay, example 2, check your understanding. So as you know from having done this before, I'd like you to stop the video, try these, see what answers you come up with, and then we'll work them together when you come back. I'll wait for you. Okay, I'm assuming you've done that. I'm hoping you've done that, stopped it and worked them out. Let's go through it. Problem A, it says find each sum. Problem A, negative 7 plus negative 4. Well, 7 plus 4 is 11. So 7 plus 4, right here. 7 plus 4 is equal to 11. So they're both negatives. So the answer is negative, right? How about B? Negative 26, negative 26.3 plus 8.9. So they're opposites. The larger absolute value would be the 26.3. It's negative. So the answer is going to be, what is 26.3 minus 8.9 is ends up being 17.4, and it's going to be negative because the add in with the larger absolute value is negative 100, negative 17.4. How about problem C? So negative 3/4, negative 3/4 plus negative 1/2. Two negatives, you're going to add these absolute values. So it's 3/4 plus a half. That's 1 and 1/4, right? And they're both negative. So that means this is negative. Okay. And when we get down to D here, 8/9 plus minus 5/6 equals the absolute value of 8/9 is 8/9. The absolute value of 5/6 is 5/6. So when you subtract the two of these, 5/6 taken away from 8/9, you're going to end up with 1/18 when you're done doing the math. 1/18. Is it positive or negative? Well, the 8/9 is definitely larger than 5/6. So the answer is positive. Positive 1/18. Okay, example 3, it's a real world problem. You can use negative numbers to model real world situations. A football team gains 2 yards and then loses 7 in 2 plays. You express the loss of 7 yards as negative 7, right? That's how you lost 7. Use addition to find the result. So what we did is you started off, you gained 2 yards plus lost 7 yards. 2 plus a negative 7 equals negative 5. So the result of the two plays, is that the football team, lost 5 yards. Okay, example 3, check your understanding. This is for you to try, as you know by now. So stop the video and work it out. I'll read it to you. The temperature falls 15 degrees. It falls 15 degrees and then rises 18 degrees. Use addition to find the change in temperature. So go ahead and work out a little problem and show us, just like we've been doing, and show us the answer here, okay? And then was it a rise or a fall, and how much was the rise or fall? The end result, okay? I'll wait. Okay, I'm going to assume they've done that and you've come back and we're going to work on it together. So the temperature falls 15 degrees. So right off the bat, I'm going to start here and I'm going to say falls 15 degrees. Okay, minus 15. It doesn't say where we started from. They don't care where we started from. And then it rises 18 degrees. Well, that means plus 18 degrees. So what does that equal to? Well, 18, these are opposite, right? 8, so we subtract them, the absolute values. 18 minus 15 is 3. Okay. And then it says, what is the larger absolute value, which is 18? And you take the sign of that number, and that number is positive. So what can we say? That positive 3 is the result, the rise of 3 degrees. And so minus 15 or negative 15 plus 18 is equal to positive 3. And the temperature rose 3 degrees. I'll write it. Temp rose 3 degrees. Okay? Okay, so now we're moving on to objective 2, applying addition. You can evaluate expressions that involve addition. Substitute a value for the variable or variables, then simplify the expression. We've done that, simplifying expressions, in previous lessons or reviews. The expression negative n means the opposite of n. So whatever n is, negative n means the opposite of it. And remember that n doesn't imply a specific number. N could be any number, but they're just saying that negative n is the opposite of whatever that number is. The expression negative n can represent a negative number, a 0, or a positive number. Okay, example 4, evaluating expressions. So you can evaluate expressions that involve addition. Substitute a value for the variables. Then simplify the expression. The expression minus n means the opposite of n, right? The expression minus n can represent a negative number, 0, or 1. So let's do it. I just repeated that to help it so it sticks in. Evaluate negative n plus 8.9. Okay, and then you get n equals negative 2.3. Okay, so what do? So we say negative n plus 8.9, that's right here, negative n plus 8.9. That equals, now we're going to substitute. What are we going to substitute? Negative 2.3 in for n. So it says negative n, so now it's negative 2.3, right? So those are going to turn out to be positive, right? Plus 8.9, substitute negative 2.3 for n. Then we're going to solve this little part right here where we have the negative times the negative, and it's going to end up being a positive 2.3. 2.3 positive plus 8.9 positive means you add the two together and take whatever the sign is. It's positive. So this, we converted the negative 3, 2.3. So now we have 2.3. We add these together, we get 11.2. That's our solution there. Okay, example 4, check your understanding. You know that means that I'm asking you to pause the video and try these and then come back and we'll work on them together. Evaluate each expression for t equals minus or negative 7.1. I'll wait. Okay, I'm sure you've taken care of that, and we're going to get going on it, right? On A, problem A, t plus, here, t plus the quantity, negative 4.3. What does that equal to, right? So we're going to put, the t is going to be negative 7.1. So negative 7.1 replaced for t plus the quantity minus 4.3. Well, they're the same, negative and a negative, so you add the two, right? And when you add the two, you're going to end up with 11.4. And what's the sign? Well, when they're the same, it's whatever the sign is. In this case, it's negative. How about problem B? Negative 2 plus t. Well, we're going to replace the t with negative 7.1. So negative 2 plus negative 7.1. And that equals what? That equals 9.1. So these are both the same. So the answer negative or positive? Well, they're both negative, so the answer is negative. You added the two because they were the same sign. Okay, how about this? In our case here, we have for C, we have 85, okay, not 85, excuse me, 8.5 plus negative t. So how do we substitute that one? Well, we say 8.5 plus the quantity negative whatever t is negative 7.1. All right, 7.1. So those two become a positive. Negative of the negative is a positive. So that's going to say 8.5 plus 7.1 is equal to 15.6. Okay, so now these are both positive, so the answer is positive. And since they were both positive, we added them. Now here we have negative t, negative 7.1 plus 7.49. These two negatives become a positive, so 7.1 plus 7.49 equals what? Equals 14.59. Now, is it positive or negative? Well, these all became positive, so this is positive. Okay? Okay, example 5, it's another real world problem. So what do we have here? We have a rock climber climbs a mountain. The base of the mountain is 132 feet below sea level. That's to get below sea level. That's pretty far down. 132 feet below sea level. So A, write an expression to represent the climber's height below or above the sea level. Okay, so we're going to do that. We don't know whether it's going to be below or above sea level, but what we do know is we're going to write it. So let's what in words, what does it want us to do? So we want to relate this to math, right? Words into math eventually here. So we're going to start off 132 feet below sea level plus the feet the route carries the climber as he's going, or he or she, I guess, going up the mountain, up the side of the mountain. So define, let h equal the feet the route rises, right? How far the climber goes up or doesn't go up, whatever that might be. So write the new equation. The new equation is negative 132 feet. That's where you start at below sea level. And then you're going to add the route, the height of the route. Now that's so whatever this h is, we'll get a different answer for however far the climber climbs. But what they're asking for is the expression is negative 132 plus h. So now part B says find the climber's height above sea level when he is 185 feet above the base of the mountain. Well, this expression is based on the base of the mountain, which is a negative 132 feet. So if we're a negative 132 feet and the climber climbs 485 feet, so there's our equation. Our new expression, minus 132 plus 485. And since they're opposite, you subtract the smaller absolute value from the larger absolute value. So 485 minus 132 is 153 feet. And is it positive or negative? Well, the largest absolute value is 485. So the answer is positive, 353 feet. His height is 353 feet above sea level. Now, example 5, check your understanding. So again, like we've been doing, I'd like you to stop the video and try it. I'll read it to you first. The temperature one winter morning is 14 degrees below 0 Fahrenheit, or negative 14 degrees Fahrenheit. Define a variable and then write an expression to find the temperature after it changes. Okay, this is basically the same thing we've been doing. Then evaluate your expression for a decrease of 11 degrees Fahrenheit. So go ahead and stop. And when you come back, I'll wait for you. We'll write this up. Okay. I'm assuming you've done that, so let's get moving on it. The temperature one winter morning is negative 14 degrees Fahrenheit. Define a variable and then write an expression to find the temperature after it changes. Then evaluate your expression for a decrease of 11 degrees Fahrenheit. Okay, so what is it? It's in the morning, it was negative 14 degrees Fahrenheit. So we're going to start off right there. Negative 14 degrees. Negative 14. And then it says define a variable. So I'm going to say let, I don't know, the change, C equal a change. Okay, C equals the change. So now we're going to add the change, right? We have to add whatever the change is. In this case, it says write an expression to find the temperature after it changes. So it's the negative 14 plus the change. And that equals whatever the new temperature is. So here's our expression. Now they want us to solve it for 11 degrees decrease. So we have negative 14 plus negative 11. So these are the same. What do we do? When they're the same, we add them. So 14 and 11 is 25, right? 25. And they're both the same. They're both negative. So that means we just use the negative sign. That's whatever the sign is. And I'll say degrees Fahrenheit is the new temperature. Okay? Say, objective 2 continued, applying addition. You can use matrices to add real numbers. A matrix is a rectangular arrangement of numbers in rows and columns. The plural of the word matrix is matrices, pronounced matrices. The mix below shows, the matrix below shows the data in a table. Okay, so the data they're talking about is we have this little school enrollment in millions, right? And it says elementary was 29.3 public and 3.1 private. And high school is 14.6 public and 1.2 million, that is, in private schools. And then college is 12.1 million students. And then private college, that's public colleges. And in private colleges, it's 3.3. I'm sorry, it's a little small, but it's the way the picture ended up being. So, but the table is bigger. So here's a matrix, and the matrix shows 3 entries vertically and 2 entries, well, I should say 3 entries horizontally, excuse me, and 2 entries vertically. So, and these are rows. So we have one row here, a row one, elementary is a row, high school is a row, and college is a row. And then columns, you have public is a column and private is a column. Okay. So this is the matrix, and every one of these numbers in this matrix is one of the elements we've been talking about. It's an element. And what they're going to say is you identify the size of a matrix by the number of rows and the number of columns. The matrix above has 3 rows and 2 columns. So it is a 3 by 2 matrix. Each item in the matrix is an element of the matrix. Okay? So matrices are equal if the elements in the corresponding positions are equal. Corresponding positions are, as you go back and forth and you look, this matrix is a 2 by 2. This is a 2 by 2. You see 2 rows and 2 columns. And you have -1 and -1. 2 and 4 halves is 2. 4 and 20 over 5 is 4, and 0 and 0. So these values are equal. So these, it says here, matrices are equal if the elements in corresponding positions are equal. So they're all equal. This is an equal, both of these are equal, despite the fact that the numbers look different. They're still the same number. You add matrices that are the same size by adding the corresponding elements. So these matrices are the same size. You can therefore add the matrices. In the next slide, we'll see how you add them. Okay? Okay, example 6, adding matrices. So we're going to go over an example showing you how to add matrices. I've got it all colored up so it kind of is clear as you're looking at it. So it says add. These are 2 by 2 matrices, by the way. They have 4 elements each, 2 times 2, 4 elements each. So we're going to add -5, 2.7, 7, and -3 or -3. The next matrix is going to be -3, -3.9, -4, and 2. So when you add them, what do we do? Well, you see I have the 5 and the 3 here. Here the 5 and the 3 are blue. Well, over here in the matrix where we're adding them, you see I'm adding the blues, the -5 and -3. And then I'm adding the green one. So here the 2.7 and the -3.9. Here it is 2.7 plus -3.9. Then I go down to the row number 2 and column number 1. And now it's 7 and 7. 7 and -4. And when you look here, it's 7 plus -4. And then finally, in the second row, second column, -3 plus 2. So here we are, -3 plus 2. So now each one of those is a little math problem, little addition problem, and you add them. Now in the final matrix, the answer is -5 plus -3 is -8. 2.7 plus -3.9 is -2.1 right there. How about 7 minus 3 is 3, is 7. What did I do wrong here? Oh, I'm finding 7 minus, excuse me, it's late in the day for me. 7 plus -4 is 3. Okay. And then finally, -3 plus 2 is -1. Okay. Hopefully that didn't confuse you. I was supposed to add each of these individually, and I started jumping to try to add the 2 of these again. It was kind of like a little memory mysteriousness here. Okay. Okay, example 6, check your understanding. You know what that means. I'm going to ask you to do these on your own. Find each sum. It's not going to be hard. Um, I'll talk a little bit with you about it before we stop it here and let you go do it on your own. But now you see that this is 3 rows and 1 column each. So the addition is going to be a matrix, just to let you know, of when you're done, it's going to have 3 values in it, right? I'm not going to tell you any more than that, but you see that. And then these are just like we just previously did. So it's going to be a square matrix with answers like that, okay? So go ahead and give it a try. I'll wait for you. Okay, so now I'm sure you've taken time to do that, and I moved ahead on you and I worked it out, and I have the solutions written up here. So find each sum. So we're going to do the same thing here. We're going to take, this is a 3-row, 1 column, 3 by 1, 3-element matrix. The first one is here. And this other one here is the same, so they have to be the same size, otherwise you can't add them. So 5 plus -9, here's 5 plus -9. Here's 3.2 plus -1.7, 3.2 plus -1.7, and -4.9 plus -11.1. Here they are right here, okay? And then when you add these, and now I know you're fully versed in adding these numbers. 5 minus 9, so to speak, is -4. 3.2 minus 1.7 is 1.45 positive. -4.9 minus 11.1 is -16. These two add together, and then you take the negative sign. And how about B? This is a 4 by 4. So -4 plus -5 is -4 plus -5 right here. And then you have 7/8 minus 3/4, 7/8 minus 3/4, and then we have 3/4 minus 1/2, or plus 1/2, 3/4 plus 1/2, and then finally we have 0 minus 1, 0 plus a -1. And when you do this, -4 plus -5 is -9. 7/8 minus 3/4 is 1/8. 3/4 plus 1.5 is 5/4 or 1 1/4. And 0 plus -1 is -1. Okay, good job, everyone.